Hi, this is Mrs. Rodriguez, your pre-algebra teacher. This video is a review for the Chapter 8 quiz that's coming up. Okay, so remember this is a practice quiz that's from your textbook, and I selected problems that are very similar to the ones that you're going to see on the quiz, and I may have added a couple if I didn't see them in the practice quiz there. Okay, so what I recommend that you do is you grab some paper and something to write with, and when the problem comes up on the screen, pause it, try to solve the problem yourself, and then play the video. If you get the correct answer, great, move on to the next one. If you get it wrong, try to figure out your mistake. And if you cannot figure out your mistake, then please stop on my office hours or email me, and I'd be happy to explain it to you. Okay, so let's go ahead and get started. Okay, so okay, here we go. All right, so like I said, this was a review for the Chapter 8 quiz for pre-algebra, and these questions are from a practice quiz that can be found on page 431 of your textbook. Okay, so first section is about functions. Okay, so recall that functions are relations in which each element or each term of the domain is paired with exactly one element of the range. So basically each x value can only match to one y value. Remember, domain are the x values, and then the range are the y values. Okay, so this would be an example of a function because one element from the domain matches one element of the range for every single element within the domain. Here, this would not be a function because the 2 in the domain matches with a 1 and also a positive 3, so that would not be a function. Okay, so you will have a question like this on your quiz. It says determine whether each relation is a function and then explain. Okay, so what I would do is I would just put all of the x values in a list there. Okay, and then all of would be your domain. Okay, and then over here is your range, which are the y values. So that'd be 5, 2, -3, and 4. So 5, 2, -3, and 4. So 0 matches to 5, 1 matches to 2, but it also matches to -3, okay? And then 2 matches to the 4. So this would not be a function, okay? Because one element from the domain matches with 2 different elements from the range. So this is not a function, okay? All right, let's look at another one. Oops, sorry. Same question, determine whether each relation is a function. So again, I would list all my x values for the domain, -6, -3, 0, and 3. So -6, -3, 0, and +3. And then the range, I wanted to change the color there. Okay, the range is going to be 3.5, 4.0, 4.5, and 5.0. So 3.5, 4.0, 4.5, and 5.0. Okay, so -6 matches with 3.5, -3 matches with 4.0, 0 matches with 4.5, and 3 matches with 5.0. Okay, so yes, this is a function, okay, and the reason is because each element in the domain matches with one element in the range, okay? All right, let's look at the next section. The next section talks about describing sequences, okay? A sequence is an ordered list of numbers. Each number is called a term of the sequence. When the difference between any 2 consecutive terms is the same, the sequence is called arithmetic sequence, okay? And the difference is called the common difference. And then you can use rules to extend patterns and find other terms. Okay, so you'll have a problem where it'll ask you to write an equation that describes each sequence and then find the indicated term. Okay, so here is the sequence. These are the terms in the sequence. And then you also, once you find the pattern and then use that to help you come up with an equation, then you're going to be asked to come up with the 15th term. Okay, so what I like to do is just to make a quick table here. So I have the first term is 12, the second term is 13, the third term is 14, and the fourth term is 15. Okay, so then I have to figure out, okay, well, what is my common difference here? So what happens from, how do I get from 12 to 13? Well, that's an increase of 1. 13 to 14, that's also an increase of 1, and 14 to 15 is also an increase of 1. So I know everything is increasing by 1. However, when you're coming up with the equation, because you might think, oh, I'm going to be adding 1 to something, okay? But when you're coming up with an equation, you have to figure out, well, what am I doing to x to get y? Okay, so I can't just add 1 to x, okay? Because some of you might be thinking, oh, okay, it's going to be x plus 1. Well, if I put 1 in for x, 1 plus 1 is going to be 2, not 12, okay? So it cannot be x plus 1, okay? So what am I doing to x that is going to give me 12? Well, if I add x plus 11, because I know 1 plus 11 is 12, so 1 plus 11 is 12. Does that work for my second term? 2 plus 11, well, that's 13, so that works. 3 plus 11 is 14, so that one works. And then 4 plus 11, that's 15, so that works. So my equation is going to be x plus 11 equals y, okay? And then the second part of the question is asking you, okay, now find the 15th term. Okay, so that means I'm going to plug in 15 for x because x is the number of my term, and then add 11 to that, and 15 plus 11 is going to be 26, okay? So my equation is x plus 11 equals y, and then the second part, the 15th term, is equal to 26, okay? All right, so next problem. Same thing, we have a sequence, so I'm going to put my x and y. So first, second, third, and fourth term. First term is 6, second term is 11, third term is 16, fourth term is 21. Okay, well, I can see that the common difference to go from 6 to 11, that's an increase of 5. Also from 11 to 16 is an increase of 5, and 16 to 21 is another increase of 5, okay? So remember, you might think, oh, okay, well, x plus 5, right? Okay, so x plus 5 is 6, right? For the first term, 1 plus 5 is equal to 6, so that works. But remember, it has to work for each term. So if I put in 2 plus 5, well, that's 7, not 11. So it cannot be x plus 5, okay? Now I'm increasing by 5, so I'm going to be multiplying by 5. And then if I multiply my first term by 5, well, that just gives me 5. I need to get to 6. Well, if I add one more, that gives me to 6, right? So I can test this out. 5 times 1 plus 1 is equal to 6. It works for the first term. Let's try the second term. So 5 times 2 is 10 plus 1 is 11. So that works. Let's try for the third term. 5 times 3 is 15 plus 1 is 16. So that works. And then the last term, 5 times 4 is 20 plus 1 is 21. So that works, okay? So my equation is going to be 5x plus 1 is equal to y, okay? Then it asks for the 30th term. So in place of x, I'm going to put 30, and that's going to give me y. So 5 times 30 is 150, plus 1 is equal to 151. Okay? All right. So just make sure when you're coming up with equations that it works for each term, because it, like for this one, it worked for the first term, but not the remaining terms. Okay? So it's got to work for all of them. Okay, next section talks about solving linear equations. So here we have an example, y equals 60x, that's in a linear equation. A linear equation is an equation whose graph is a line, okay? A linear equation is also a function because each member of the domain, the x values, is paired with exactly one member of the range. That's how you get a straight line, right? So the solution of an equation with two variables consists of two numbers, one for each variable, that make the equation true. One way to find solutions is to make a table, okay? So here we need to know these terms. We need to know the x-intercept, okay? The x-intercept is where the line crosses the x value, okay? Y-intercept is when the line crosses the y value, okay? So it says since 2 points determine a straight line, a simple method of graphing a linear equation is to find the points where the graph crosses the x and the y axis and connect them, okay? All right, so that way, once you have 2 points, you only need 2 points to draw a line, okay? You don't need 5, 10, 15, okay? You just need 2, and that will tell you what the line is gonna look like. All right, so for number 16, it says to find 4 solutions of each equation and then write the solutions as ordered pairs. Okay, now in this lesson 8-3, it asks you to use for your values, and I'm just going to make a t-table here. Okay, it asks you to use -1, 0, 1, and 2 as your 4 values. Okay, so we're just going to stick with that. And this is y equals -4x minus 7. So all we're doing is plugging in each one of these x values into this equation and solving for y, okay? So I've got -4 times x, which is -1, minus 7. And then I solve. So -4 times -4, that's going to be +4. And 4 minus 7, I add the opposite, that's going to be -3. Okay, and then when x is 0, I've got -4 times 0 minus 7. So -4 times 0 is 0. 0 minus 7 is -7. I put in 1 for x, and I get -4 times 1. Well, that's -4 minus 7. I add the opposite. -4 plus -4 is -11. And then when I put in 2 in for x, -4 times 2 minus 7, -4 times 2 is -8 minus 7, I add the opposite. So now I've got -8 plus -7 is -15, okay? And it says to write the solutions as ordered pairs so that an ordered pair, remember, has an x value and a y value, okay? So my first ordered pair is -1, -3. Okay, here was my -1 and my y value was -3. Now I've got 0 and -7. And then I've got 1 and -11. And then I've got 2 and -15. And those are my ordered pairs, okay? So remember to use the values -1, 0, 1, and 2 as your 4 values, okay? All right, so this problem here says to graph each equation, okay? So again, we're going to use, we could use those 4 values, or we can also use the x and the y-intercept like I mentioned earlier, okay? So let's say we were using the y-intercept. So we plug in 0 in for x. Okay, so we've got y equals 0 plus 2. So it's, we have y equals 0 plus 2 is 2. So the y-intercept is +2. Okay. Okay. +2, and then the x-intercept we plug in. Let me change colors here. For the x-intercept, we're going to put in 0 for y, and then solve for x. Okay, so then I would subtract 2 from both sides. I've got -2 equals x. So my x-intercept, it crosses the x-axis at -2. So now I have my 2 points. That's all I need to graph my line. Okay, another thing I could have done to graph this is to use a table of values. I could have plugged in -1, 0, 1, 2, and solved for y, and then I could have plotted those points as well. Okay, but whatever is easier for you. It doesn't give you a specific method of how to graph the equation, so it's up to you how you want to graph it on the quiz. Okay, all right. But you need to be familiar with how to use all of these methods, okay? This is going to be very important in algebra, okay? All right. So rate of change. A rate of change is a rate that describes how one quantity changes in relation to another quantity. The rate of change of the height of a kite surfer, so here we've got this kite surfing graph, and here's the height. So the rate of change of the height of the kite surfer to the time from point B to C is 10 minus 4, and then 6 minus 4, okay, or 3 feet per second, okay? So we want the change in the variable on the y-axis, and then the change in the variable on the x-axis, okay? So we need to be able to find ordered pairs, okay? All right, so some things you need to keep in mind when dealing with rate of change. If the line is going up from left to right, okay, you might be thinking, well, it's going down this way, but you have to imagine a person walking along the line, okay? So if they're walking up, then that is a positive rate of change. If the person is walking down, okay, then that is a negative rate of change, okay? And then if the person is just walking straight across, well, that's a 0 rate of change, okay? All right. So it says to find the rate of change for each linear function, okay? So we're going to find, here's our y value, okay, over here, the amount saved is our y value. So we want to find the change in the amount saved, and we're going to put that over the change of the x value, which is the number of weeks. Okay, so change in number of weeks. Okay, so we're just going to pick the first 2 points here. So I'm looking at, oopsie. Okay, so I'm looking at these 2 points here, okay? So I want the change, so I'm going to put 40 minus 25, and then my x values, I'm going to put 4 minus 3. So 40 minus 25, that gives me 15, and 4 minus 3 is 1. So that means there's a change of $15 per week, and this is an increase, okay? So increase, oh, that looks helpful. Okay, I'll write down here, increase of $15 per week, okay? That is the rate of change. All right. Then it talks about constant rates of change. Has a graph here. and it has a straight line, and a relationship that has a straight line is called a linear relationship. And this is the time is increasing by 1, and then the number of heartbeats is increasing by 2, okay? So make sure if you're given a graph and you're asked for the rate of change, you're looking at the intervals, okay? It's not always going up by 1, okay? It could be going up by 2, 5, 10, 100, 1,000, a million. It just depends on the graph, okay? So make sure you pay extra close attention, okay? So here again, we're talking about constant rates of change. So it could go steadily increasing up, steadily decreasing. This would not be a constant rate of change, okay? All right, and then it talks about direct variation, okay? And then for direct variation, it's a relationship in which the ratio of y to x is a constant, which we call k, and we say y varies directly with x, okay? So here, very important, this little equation here, y equals kx, okay? All right, so for this particular graph, the k value, which would be the constant, is 2, okay? So it's increasing by 2, okay? All right, let's look at this problem here. Number 22, it says to find the constant rate of change for the linear function shown below and interpret its meaning, okay? So remember, we want the change in y over the change in x, okay? So our y value is the profit. So on top, we want the change in profit. And then down below, our denominator is the change in number sold, okay? Okay, so now we've got to get select two terms. So let's say we're using this point here. The coordinates are 10, 40, okay, because we're going over 10. We're not going over 2. Make sure you're looking at the intervals here. This is by tens. And then we're going up not 2, but 40, okay? So the x value is 10, the y value is 40. And then for this point here, our x value is halfway between 20 and 30, which would be 25. And then the y value is halfway between 80 and 120. So that would be 100. Okay, so those are the 2 points I'm going to be using. So for my change in profit, I went from 40 to 100, right? So I need a difference. So 100 minus 40, and then from 10 to 25, so I'm going to find the difference between 25 and 10. So 100 minus 40 is 60, 25 minus 10 is 15, and 60 divided by 15 we can simplify, and it ends up being 4. So it's $4 is the profit per shirt. Okay, so the profit is $4 per shirt. Okay. Okay, so that is the conclusion of the review. Hopefully this was helpful to you for the quiz, the Chapter 8 quiz for pre-algebra. If you went through this review and you had questions about anything, or you're like, I don't understand what she's talking about for that problem, please, please, please either email me or stop by my office hours, and I'll be happy to help. That's what I'm here for. Okay? All right, you have a great day, and hopefully I'll see you soon.